Welcome to this FP2 video on reducible first order differential equations. So these are when we can use a substitution to reduce a first order differential equation into a form that we already know how to solve. Okay, then we can either separate the variables or use an integrating factor. Now, in terms of in questions, you'll always be given the substitution. Okay, so the spec says differential equations reducible to the above type, so like the types that we've already looked at in the last two videos, by means of a given substitution. So you'll always be given the substitution for these. So let's not beat around the bush, let's jump into the first example. So here's our example. We need to use the substitution z equals y to the power minus 2 to transform this differential equation into this differential equation. So first start off with the substitution. So z equals y to the minus 2. And then we want to differentiate this. So we're going to differentiate. So we're going to differentiate with respect to x. So this will be dz by dx. Now this will be, so differentiate the y to the minus 2. So it's going to become minus 2y to the minus 3. And then multiplied by dy by dx. And if I rearrange this for dy by dx, I will get minus a half, isn't it, divided by 2, and then y cubed dz by dx. So minus 2 comes down. This y to the minus 3 is on the bottom, isn't it, really? It comes up to the y to the power 3. And now we substitute in. So instead of dy by dx, we have minus a half y cubed dz by dx. Then we've got a half tan x multiplied by y equals minus 2 sec x y cubed. Now, if I divide by y cubed, then on this left side, this y is going to become y to the minus 2, and this y will become 1. So first I'll divide by y cubed, so then it gives me minus a half dz by dx plus a half tan x y to the minus 2 equals minus 2 sec x. Now this y to the minus 2 is up here as z. So this is now, let me just make a bit of room. So as I was saying, this is now minus a half dz by dx plus a half tan x times z equals minus 2 sec x. Now if I check out what I want 1 dz by dx, and I've got currently minus a half. So if I multiply through by minus 2, I'll then get a positive dz by dx. Multiplying by minus 2, this will become minus tan times z. Sorry, I rubbed that out. So minus z tan x. And this will become positive 4 sec x. Now, comparing with the top, that's right, and that's right. So now we have done what we needed to do for part A. We've converted it. So that's how you use a substitution to convert a differential equation into a differential equation of the form in which we can solve. And part B is now we're going to solve it. Now remember, when it's of this form, dy by dx plus py equals q, we can obtain the integrating factor by e to the integral of p dx. Now obviously in this case we're looking at dz by dx instead of y, but it's the same thing. Okay, the y's here are just replaced by the z's in this one. So that's my dz by dx, my dy by dx, py, so it's pz. So this is going to be p minus tan x, and then that's just q. Okay, so I am looking at my integrating factor as e to the integral of minus tan x dx. Now if we take the minus outside and then integrate tan x dx, you can look in your formula book and it will give me minus ln sec x. Okay, now to make it positive, you can learn this or remember it, but this is actually going to be cos x. So this will be to the power minus 1 using the rules of logs. So e to the ln sec to the minus 1x, which is e to the ln 1 over sec x, which of course is e to the ln cos x. And this is just simply cos x. Okay, so that is kind of how we can go about sorting this out. Obviously I could have actually brought this down almost straight away, but it wouldn't have quite worked out. It would have been the minus sec, so it's easier to deal with it while it's as a log up here. Okay, so my integrating factor in this case is going to be cos x. So multiplying through by cos x, I get cos x dz by dx minus z sine x, because the causes will cancel, and then equals 4, because obviously the sec x times cos x will be just 1 as well. That'll cancel itself out. Okay, so now I've got a nice straightforward differential equation to solve. Now this on the left will come from differentiating z cos x. Sorry, that looks a bit like a 2. It is a z, I promise. And that equals 4. Then what we want to do is we want to integrate both sides. So integrating the left is just going to give me z cos x, and integrating the right will give me 4x plus c. Now I just want to make z equals, so z equals 4x plus c over cos x. Now since z equaled y to the minus 2, which is 1 over y squared, we can substitute that in for our z. So we got 1 over y squared equals 4x plus c over cos x. And we should make this y equals, so flip it first, so y squared equals cos x over 4x plus c, then square root in, so we've got square root of cos x over 4x plus c. And there we have it. So we've solved the transformed equation and then we've converted it, given it y in terms of x. Okay, so that's all there is to it in this section, just a substitution as an extra step. So what I'll do now is I'll just give you a couple of questions to have a go at, and as always I'll put the answers at the end. Okay, if you found the video useful so far though, don't forget to hit that like button, subscribe if you're yet to subscribe, and if you feel like and you're able to donate to help me out, then please do think about joining, even if it's just for like a month. Anyway, let's look at the questions. So these are all past paper questions. I've got 3 for you to try. Pause the video, try them, and then resume then to see the solutions. Okay, let's have a look at the solutions. Now, I've just realised they've given me quite a harder one to start off with, because we've got this in terms of z and x, but this in terms of x and t. So there's a little bit of an issue there. So the first thing I want to do is differentiate this, x to the power a half, with respect to t. So that'll be it won't be minus a half, that'll be a half x to the minus a half, and then dx by dt. And since x to the power half is z, this is dz by dt. So this is actually dz by dt, which is what we were doing. Now I've got something in z's and z's and t's and x's and t's, and obviously we want z's and t's, and this one currently contains x's and t's. So we need to rearrange this. So we want dx by dt. So we're going to multiply by 2 x to the power, not minus a half, sorry, x to the power a half dz by dt. Oh, sorry, that was actually really easy. I don't know why I made a fuss of this up here. Should have just didn't dz, differentiate the z with respect to t right from the start. Well, my brain having a bit of a meltdown there. Anyway, it's not as hard as I initially said. It's actually really straightforward. And obviously we don't want any x's, so dx by dt is 2. Now this is z, isn't it? X to the power a half dz by dt. So there I've got it, and I can substitute this now into this. Sorry, into this. Not that, this. That was what I was aiming for. So 2z dz by dt plus t squared x plus t, not plus, that's equals t squared x to the power a half. So that's 2z dz by dt plus t squared. Now x, so x to the power half is z, so x will be z squared if you square both sides there. So this is z squared, t squared, z. Okay, so we're getting there now. If we look up here, we're very close to it. So if we divide by 2 and the z, this is going to become dz by dt, plus divide by 2, so this will be a half t squared, divide by z, so this will be a single z, and then divide by 2, so this is a half t squared, and divide by z, so this will disappear. Now this is the same as up there, so as required. Now all that's left to do is basically finish the question off for the part B, solve it, and then find the general solution to the original equation in terms of given x in terms of t. So let's find the integrative factor. So we're going to integrate a half, take that outside, t squared. Normally x, but in this case it's t. So integrating that, we get e to the minus a half. This is going to become t cubed over 3. So we've got e to the t cubed over 6. That's it. So let's multiply through by that. So e to the t cubed over 6 dz by dt plus half e to the t cubed over 6 times t squared times z equals e to the t cubed over 6 divided by 2 and times by t squared. So on the right side I've got this, which is going to be e to the t cubed over 6 times z. Now integrating both sides, so I'm just going to carry on up here. We get e, let's put the z in front, z e to the t cubed over 6 equals e to the t cubed over 6 plus c. And if you want to just double check it, if you're starting with e to the t cubed over 6 and differentiate this, we get e to the t cubed over 6, that stays the same, multiplied by this power differentiated, which will be 3t squared over 6. These will cancel, leaving you with a half, so a half t squared e to the t cubed over 6, which is that there. So integrating this gets me to this, Okay, so that is the integration part done. Now dividing through by e to the t cubed over 6, we get z equals 1 plus c. Now divided by it, so I can put e to the t cubed over 6 and a minus power, because obviously if we divided by it would be in the bottom, but to write it on the top, just the minus power there. And then we know that z equals x to the half, so x to the half equals this, c e to the minus t cubed over 6 and then squaring it for x. No need to make it too complicated. We'll just square both sides. And there we have it, x in terms of t. Hopefully you managed to get that one out. Let's move on and have a look at the second question. So we've got z equals y to the minus 1. Right, now let's differentiate. dz by dx equals minus y to the minus 2 dy by dx. Now this is dz by dx equals minus, now y to the minus 2, y to the minus 1 is z, so if I square them both, so y to the minus 2 will be z squared, won't it? So this is z squared dy by dx, and then we want dy by dx equals, so divide by minus z, so we get minus z to the minus 2 dz by dx. Okay, so now let's go ahead and substitute that in. So dy by dx is being replaced with minus z squared dz by dx minus now 1 over x, and it's y, so y will be z to the minus 1 equals x plus 1 cubed over 3, and y squared will be z to the minus 2. Okay, so that's what I've got so far. Now, this is a minus 2 there. Now let's multiply through by minus z squared. So minus z squared times by minus z to the minus 2 will just be 1. So that's going to be dz by dx minus, and the minus will make this a plus. The 1 over x is not changed, and then we're multiplying by z squared. So this will become z, and then x plus 1 cubed over, that's over x, not 3. Don't know what I'm doing there. And multiplying by z squared, this will disappear. So now I've got this, and let's look up here. Oh, and it was multiplying by minus, wasn't it? So this becomes minus, and then that is right. So there we have it, part A complete. So now we have to solve this and then convert it, giving it y equals, so y in terms of x. So let's work out the integrating factor. We're integrating 1 over x dx is e to the ln x, which is just x. So we've got x dz by dx plus z equals minus x plus 1 cubed. Okay, so the left side is dz, not dz, is dxz by dx, and then that's the right hand side, and integrating both sides we get xz on the left, and then we're integrating minus x plus 1 cubed dx. So this is going to become minus x plus 1 to the power 4 divided by 4 multiplied by the inside differentiated is just 1 plus c. So that's what I've got there. So if I want to make this all minus and one big fraction, this will be x plus 1 to the power 4 plus, no, it'll be minus 4c over 4. Because then the two, this minus is for all of this, isn't it? So I can turn this into a positive by kind of timesing through by -1, but I also want to divide by x. So let's divide by x first. So z equals minus, now we've got x plus 1 to the power 4 minus 4c over 4x. So z equals 4z minus x plus 1 to the power 4 over 4x. And this 4c I could just replace with, say, a k. So let 4c equals k. So I could just have z equals k minus x plus 1 to the power 4 over 4x. It doesn't really matter. Now, z is 1 over y. Therefore, y is equal to 4x over k minus x plus 1 to the power 4. And there we have it. Obviously, let me know in the comments what you did with this, with the constant, how you went about it. Sometimes it's a little bit confusing with a negative integral, but, you know, adding a constant, the constant could be negative value anyway, isn't it? So it's all a bit, you know, it's just plus a constant. But let me know what you did, whether you started kept it as a minus c, for example, here because of the minus. But yeah, let me know. I'll be interested to find out. Right, let's look at the last question. Okay then, so this one's a little bit different. It gives me a substitution of u equals y plus 2x. And there is my differential equation, but it doesn't tell me what the differential equation should look like. Okay, so, you know, realistically, oh, it's in terms of u and x. So that does help me out a little bit. So I'm going to have to replace this dy by dx. So let's start with this substitution and rearrange for y. So y equals u minus 2x, and then dy by dx will equal u d, nope, this will be du by dx minus 2. Okay, it might have been, you know, easier to go from up here. Du by dx equals dy by dx plus 2. It doesn't make any real odds there. So let's go ahead and substitute in. So dy by dx is du by dx equals minus, now 1 plus 2y, so it's 2u minus 2x plus 4x over 1 plus u minus 2x plus 2x on the bottom. And sorry, this was du by dx minus 2. Okay, so let's sort this bracket out. 1 plus 2u minus 4x plus 4x over 1 plus u. The 2x's will cancel, so the 2x's cancel there, and these 4x's will cancel there, leaving me minus 1 plus 2u over 1 plus u. Now, taking the 2 over du by dx, we have 2 minus 1 plus 2u over 1 plus u. So if I make the 2 a fraction, so I'm going to go up here, so du by dx equals, so I'm doing 2 1 plus u over 1 plus u minus 1 plus 2u over 1 plus u. So this is 2 plus 2u minus 1 minus 2u over 1 plus u, which is 2 take away 1, which is 1, and 2u take away 2u. These will cancel. So 1 plus u. So my du by dx is just simply equal to 1 plus u. And now that there is a differential equation in u and x. Well, it's just in u, I suppose, but the du by dx is obviously the x there. Now, by first solving this new equation, show that the general solution to the original equation may be written as that, where k is a constant. Right, let's make a little bit of room. Okay, let's oh no, not du. So let's integrate. So 1 plus u du, and this will be the dx on this side. So we've got u plus u squared over 2 equals x plus c. Nice and easy. Multiply through by 2. So I've got u squared plus 2u equals 2x plus 2c. Now, since what was the substitution? U equals y plus 2x. This will be y plus 2x squared plus 2 lots of 1 y plus 2x equals 2x plus c. So now I need to expand this. So this is going to give me y squared plus 4xy plus 4x squared. Now second bracket plus 2y plus 4x equals 2x plus, and sorry, this was at 2c, wasn't it? 2c. Now let's get it in the order that they've written it. So 4x squared plus 4xy, that's what we've got, plus y squared plus 2y, and then I've got 4x, but taking away 2x will give me 2x equals 2c, and c is just a constant, so I can then just replace it with a k. And there we have it, where k equals 2c. Okay, so that's question 3 done. Now, I don't think there's anything too difficult about these questions. If you get a substitution, you just go to the substitution first, and then you've got an equation to solve. Okay, these are all past paper questions, so if you had ones like 1 and 2, you already know what part A should look like, so you can always do part B, even if you kind of mess up part A. Okay, this one was a little bit different. It didn't give you what you were aiming for part A. Okay, but nevertheless, I think this is just straightforward. If you get a substitution, it's just going to be a few extra marks in the question, as opposed to just a differential equations question. Okay, anyway, that's it for this video. Don't forget to like, subscribe, and consider joining. Okay, it does help me out. You may have noticed that there's some big gaps between my videos because obviously I've got work and things, but the more people that can join and help me out, then the more time I can commit to making these videos. Okay, so please do help me out there. Anyway, see you in the next one.